you mute.
Sorry. Hello, everyone, and thank you for joining our session today. Let's talk chaos engineering with Harness. This is the first part of DevOps practices and processes for modern cloud-native app series. My name is Pulina, and I'm a senior DevOps engineer based in Abu Dhabi. My passions are automation and innovation. I love using my skills to contribute to the development processes while acquiring new skills in the meantime. Besides my work, I love traveling, swimming, skiing, um, participating in the challenging events like Spartan races. And now it's time for our speakers to introduce themselves, Prithvi Arash and Sayan Mundal.
Hey everyone, nice to meet you. This is Prithviraj here. Thanks again, Polina and Walid, for organizing this amazing meetup, and we are glad to be joining you folks. And my name is Prithviraj. I am based out of Bhubaneswar, India, and I have been working on the LitmusChaos project as a community manager since the past 2 years. LitmusChaos is a CNCF incubating project. We'll talk about it more. And other than that, I have been part of various community events as a co-organizer, namely Chaos Carnival, Kubernetes Community Days KCD, Bangalore and Chennai. And then other than that, I have been part of the chaos engineering community since long, and I've been organizing chaos engineering meetups every month. And it's more about chaos engineering only from my end in the CNCF space. And other than that, as you know, I'm part of the Harness team as a technical community manager, participating in their community. Sayan, you can go ahead.
Thank you, Prithvi. Thanks for the intro. So hi everyone. I'm really glad to be here. It's a great opportunity, and thanks for having us again. As for me, my name is Shayan. I am a senior software engineer at Harness, and I work on the Litmus community side as the one of the maintainers or one of the core members who manages and maintains the project along with a team of other members as well. And apart from the open source side, there are two projects as well which are built on top of the open source, Litmus, which is the Harness module that we are going to talk about today. So those I also work as a software engineer on those projects. So yeah, really excited to share the progress, the things you can do with the updated versions as a wrapper of the open source one. We're also going to take a look at the open source product, take a look at the new features, and yeah, and do some hands-on demos. Yeah, really excited.
Okay, so let's start from the beginning. Uh, what is chaos engineering and what is its relation to DevOps? So Polina is starting this DevOps meetup. We would like to know, why did you choose chaos engineering as the initial session? Why is it important? What it is exactly?
Well, I've heard in the chaos engineering in the past in my previous companies. We've tried to implement it a little bit, and I would like to learn more, like how it can be integrated with Kubernetes environment.
Okay, Sai and
Awesome.
Britain, can
Sure, Walid. Awesome, Pauline. I think the idea of featuring chaos engineering is amazing. Is an amazing one, and chaos engineering, as you know, or many people might not know, was a practice introduced by Netflix, where they just started production testing and started inducing faults in their systems to identify real life chaotic scenarios that can happen, or real life disruptions or vulnerabilities present in the system that can disrupt the day-to-day production systems. And soon after, the open source project Chaos Monkey came into play, and then the idea was to expand the whole implementation or ideation of chaos engineering, that is deliberately inducing a fault into your system or injecting a chaotic situation scenario in your system to identify the possible faults that can happen in real life when the system goes in production, or when you are actually there is a demand for scaling, or there is a demand from the system. And the examples of chaos engineering experiments can be deleting a pod. If you're talking about the Kubernetes paradigm, then it can be deleting a pod, killing a container, your disk CPU runs, or memory loss, or such examples are day-to-day chaos engineering examples that people are experimenting with. And then it's just expanding every day to your infrastructure in form of, you are testing in production on your AWS or your Azure or your GCP or your VMs. So that's the idea of chaos engineering. And in the DevOps space, it comes more on the ops side. We'll talk about it more in our slides as well. And the idea was, it was more from the deploy, operate, and monitor side of things. And SREs started this practice, or SREs were the initial persona who were practicing chaos engineering. But slowly it moved on, and now the developer persona as well is using chaos engineering to practice resiliency, or to bring in the idea of resiliency. And it's becoming an important part of the DevOps loop. And testing in production doesn't just mean penetration or integration or the various other types of testing, but testing has actually crossed the majority adoption segment in the overall chasm, or the overall Kubernetes adoption or DevOps adoption chasm. So that's what will be an introduction to chaos engineering. But let's talk more about the history and how it goes ahead with Harness.
Polina, any questions?
I would like to see the presentation, and we'll continue with the questions later. I'm really curious about it.
Let's share the presentation.
Absolutely. So I'll be talking about, chaos engineering and the history, and introducing the open source Litmus project to you, what chaos engineering exactly is. And then Sayan will be talking about the Harness chaos engineering platform, and hopefully we'll have a quick demo from him as well. So let me share my screen. Can you guys see my screen?
Yes.
Yes.
All right, so let's get started. Let's talk chaos engineering with Harness. I think we both have introduced ourselves, so I won't take a lot of time. I've been working as a community manager for the LitmusChaos project, part of the Harness team now. It all started off at Magata, and now then Chaos Native, and now part of Harness. And I think Sayan has also introduced himself. So let's move ahead, and let's see what the agenda for today is. We'll be introducing chaos engineering. We'll be talking about LitmusChaos a little bit, and the Harness chaos engineering platform. We'll talk about how the journey of LitmusChaos came out and became gave the ideation of Harness chaos engineering the wings. And then we'll be diving into the core components, and then a little bit of a demo, and then the future roadmap, which obviously will help people understand what's next in this journey for us. So let's move ahead. Act 1, chaos engineering, a closer look. So before we move on to chaos engineering, let's understand what exactly resiliency is, or what exactly is resilience, or what are the examples of weaknesses and resilience that usually happen in a system. And here we are taking an example of a Kubernetes system. Let's say a pod is evicted from a node, or a node goes to a not ready state, or there's a memory leak in a container. So what exactly is the example of the system being resilient or the system being weak? So a simple answer to this is the pod is rescheduled and the dependent service is healthy. So the system is resilient, or the system is still resilient in spite of such an outage or such a disruption happening in the system. But let's say the dependent service slows down or turns unhealthy, or is not able to actually cope up to this sort of an outage. then what exactly happens? The system goes down and the system turns out to be weak, and there's an outage, there's an outage in the system, and that causes downtime. Basically, that is what is the main reason of downtimes in the system. And then you need to fix the issue, and the systems are basically not resilient. So as you know, I mean, resilience is nothing but the system's ability to keep up in spite of such a disruption or a fault taking place. And that is where the whole concept of chaos engineering came into play, where the idea was to play with the possibilities of weaknesses in a system, and every system has to go down. Basically, it's not it's not that every system or any system in this world is completely resilient. It's a matter of time. It's basically, when does the system go down, or how does the system go down? That's what we need to anticipate. And it's basically Murphy's law. Like, if you anticipate something to go wrong, then it will go wrong eventually. And that's what happens with these dynamic infrastructures that we are dealing with today. It might be Kubernetes. I mean, Kubernetes adoption is at its peak, and it's growing every day. And even the whole DevOps ecosystem, the way folks are moving on from monolithic infrastructures to microservices. I mean, it's just a matter of time that you will see more and more dynamic systems coming in, and weaknesses are a part of it. Weaknesses come alongside change or development in systems. So that's what brings in the idea of chaos engineering. And let's just see what causes downtime. What are the reasons these downtimes happen? I mean, your application can fail, your infrastructure can fail, there might be operational failures. I mean, let's take an example here. Let's just take an example of, let's say in India, we are having these big billion day sales organized by Amazon, or all over the world. We have Black Friday sales. We have, I mean, so many sales, or there's a new movie or a new TV series that comes out, and people are completely in love with it, and there's a spike in the number of users in a particular platform, let's say Netflix or Amazon Prime. And that is what requires, I mean, the system to cope up with this spike in the number of users. I mean, that's part of operational failures, of course, capacity issues, but the system needs to scale, and that can actually cause any kind of issue. I mean, there can be a service timeout, there can be a device failure or a network failure, and these failures eventually cause downtime. These failures eventually impact your systems, and these outages basically can cause loss of millions of dollars. If you can see these examples from Slack, from Facebook to Amazon to British Airways, Delta Airlines, everyone has faced an outage or two in the recent few years. And that's something. These disruptions are basically something that need to be catered to, or that's what brought in the idea of chaos engineering at the first place. Why? Because outages are expensive. I mean, there are thousands of outages. You lose money, you lose confidence in your systems, and then the people, you lose confidence in your application. And there's a lot of loss of work, and a lot more that can actually harm you. I mean, that's something that you don't want, only because you did not test your systems beforehand. And that's why the idea of chaos engineering, or the chaos first principle, where why wait for an outage to happen? Why not test your systems beforehand and adjudge the capabilities of the system, the resilience of the system, and the possible weak points of the system? So I think we have seen a lot of examples here. We saw the examples of British Airways, Atlassian, Facebook, AWS. These are some of the outages that are real life examples, and that are strong examples of why chaos engineering is important. And now let's move on to, obviously, the cost. I think we talked about the cost, loss of customer confidence, damage to the brand integrity. There's, I mean, so many other impacts. I mean, there's legal action, reduced stock price, and an average downtime obviously stays for approximately 79 minutes. You don't want to have a downtime for so long. You want to mitigate this, and the best way to mitigate is obviously continuous testing. Yeah, keep on testing your systems again and again and again to identify how resilient your systems are to various sorts of real life scenarios. And that's where chaos engineering comes into play. So the chaos chaos engineering is nothing but the idea or the process of deliberately inducing a fault in your system or testing a computing system, complex system, to ensure that it can withstand any sort of possible disruptions or possible outages that can happen in real life. Just like I mentioned, the examples of downtimes that usually happen when your systems go down, and that is where chaos engineering plays a huge role, where you induce a fault.
Okay, so
Mhm. Yes, Wale.
so basically, if I understand you well, in the DevOps traditional software development life cycle, it will be on the testing phase. Like, so we can consider this part of the testing phase, or is it after deployment? Uh, this could be like gamification to enhance operator skills and stuff like that. In what phase usually you see it in the DevOps cycle?
So a lot of people believe that where in the DevOps space you can use chaos engineering, but the belief is that you can use chaos engineering in any sort of any phase while you're developing. I mean, you can use in your CI/CD or in your development stage, or in your pre-staging, or in your staging platform, or your staging. But if you see it from a testing perspective, then chaos engineering is not just testing your systems, but it's a continuous process where if one disruption, or let's say one fault that you test is validated, let's say you're having your SLOs, the SLOs are validated, then you go on to the next fault. You check out the next possible disruption that can happen. So, and eventually the goal is to use it in the deployment phase where you are deploying in production. That's why it comes more on the ops side. But as I said, that now it's activating the overall DevOps loop. So chaos engineering basically can come in each phase of the DevOps loop. That's the overall or the major idea why chaos engineering just stands out a little different from the normal way or the regular way of testing your systems.
And
And yes, Polina.
sorry, if it's integrated in the CI system, how expensive will it be? I mean, for resources and time consumption. If it
So, I mean, it's again, you have to be ready for it. People usually are skeptical about chaos engineering because it needs a separate team. It requires a lot of idea, and only large companies started off practicing this initially. I mean, slowly with in the past couple of years, even small companies are moving on to it. But it obviously requires a separate fund allocation and a focus. So I mean, again, but again, the idea is to make it as feasible as possible, and that is why just look on to enterprise solutions. I mean, that's again just for a start. If you want to start, anyone can start, and there are amazing open source solutions out there in the form of LitmusChaos. There's Chaos Toolkit, and there are other tools as well out there in the community which help you get started. And I think it'll. I mean, the initial allocation is of certain personnel to the chaos engineering project, and identifying your systems and organizing game days. I think that's something which requires dedicated effort. But the also the belief is that with time and with so many solutions out there, and with so many possibilities out there, I think the overall cost is pretty much going down, and it just is becoming like any other testing. I mean, testing is important, and there's so much money being invested in testing and security and resiliency. So chaos engineering is becoming just another practice, a mandatory, not a mandatory yet, but a mandatory practice in future, that's pretty much feasible. And I don't think being skeptical about this practice is really helping, because majority of the folks out there, majority of the companies that I have seen and from the community as well, are participating and adopting this practice in their for their infrastructure. I hope that answers.
yeah, thank you.
So as we saw, again, I'll continue what's chaos engineering exactly and what's the idea of it. So I mean, there's a process. I think this is very important, that is identifying a process and how do the principles of chaos engineering work, and how do you identify where to run your chaos experiments, how to run your chaos experiments. So it moves on in a loop where you first, I mean, obviously select the system to test and hypothesize around it. What exactly are the real life scenarios that can happen? And you identify the, I mean, the steady state of your system. That's the first step. Where how does your system behave when it's steady, and how does your system behave when there's a real life disruption that can happen? And then you create a hypothesis around it, and then you select the actual chaos experiments that you want to run. Let's you whatever you want to simulate. Let's say an AWS failure and an EC2 failure, or anything that you want to run. You select that experiment, and then you run those chaos experiments on the target system, the system which you are testing basically. And then you observe how what's happening to the system when it's normal, what's happening when there's a disruption. I mean, there are so many observability tools out there that help you, and there's so much monitoring that's being done. And that is where you observe the results of the experiment. It's something which going along well integrated with other tools, let's say Splunk, Datadog, I mean Dynatrace, and so many more tools, Grafana. And that is where you basically find out the reality of your system, and then you use these learnings to make your systems more reliable. You basically improve your targets. You actually identify that these targets are the right ones for these particular chaos experiments, and then you build scenarios, and then you add to it. You schedule them accordingly, you use it for your teams. So these are some capabilities that obviously come alongside. I mean, that's I think a must when you're running chaos engineering. But eventually it goes as a loop, and then you again basically run or identify the steady state, and continue this loop. So we'll see this more briefly. But let's say, I mean, what does Harness believe, or what's our idea of running chaos engineering, and why is reliability a challenge today? I mean, the basic idea is that chaos engineering is required on each and every stage of your application development. Or basically, an application is in a form of a pyramid. There's your application that's on top. If let's say this is an example of a Kubernetes application, and there are hundreds and thousands of other microservices being run on these platforms, and then there's your application, and then there are other applications running, let's say a MongoDB or your Kafka, and then there are cloud native services, let's say a core DNS Envoy. I mean, your database is in form of OpenEBS, and then there are Kubernetes services running, and eventually there's your infrastructure layer, which is the final accumulation of your application. But every stage, or every layer of the pyramid needs to be, I mean, resilient. And that's where, I mean, initially legacy DevOps just suggested build one application, ship it, run it. But now with cloud native DevOps, there are hundreds of microservices. You need to, I mean, the world is dynamic. You need to ship them faster and run them in I mean, more than 100 scenarios. And that's why where there's a possibility of a failure, and that's the eventual cloud native problem. That's the problem that chaos engineering is solving, because even a failure in a single dependent service can actually get your system down. So moving on, what's the chaos engineering maturity model? How do you mature your systems? These are the hows and where you exactly test them. I mean, I gave you a scenario. It moves from a bottom to up approach, where you first move from your infrastructure layer to your application layer, you test. But the hows are basically a top down approach. You develop a scenario, you create a chaos engineering scenario, or we also call it a workflow, or basically game days are run according to that. I was talking about game days, and game days are nothing but organizing uh, the 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 implementation of specific chaos engineering scenarios according to your application to identify faults, list them, and then identify the reliability and weakness points of your system. And similarly, these chaos scenarios are developed, they are verified and automated. You want to automate the process, and then the resilience of individual components are identified, and then they are integrated into the QA. So it's basically a shift left testing module, or that's the maturity module on how you can develop. So whoever is looking forward to get started with chaos, I think that's the idea you got to follow. And I'm sure that there will be a lot of roadblocks you face, but it's the eventual goal is to ensure that your systems are resilient. So I think we have talked about this. Where does chaos engineering come in the DevOps paradigm, and the feedback loop basically gets activated by testing in production. So I won't waste a lot of time here. So how to do chaos engineering? This again from an SLO perspective, you identify the steady state conditions, you introduce a fault. If your SLOs are met, then yes, your systems are resilient. If your SLOs don't continue to be met, then there's a weakness found, and then you again move on to introduce a fault, and this loop kind of continues.
Did I hear you right? You said testing in production.
Yes.
Don't tell me testing in production in Fridays.
I mean, yeah, that's again uh, a thought
Shouldn't we
process,
test?
but
Yeah, I mean, shouldn't we apply case engineering first, like in a test environment or in a gamification environment, until
of
we are
course, that's
100%?
of course the adoption goes in such a way that you won't want to be testing in production from the first step. You need
Okay,
a development scenario, let's say as a game day. Chaos engineering game days are meant to be run because you want to be absolutely sure before moving into running chaos engineering in production. And the idea is to basically run the eventual idea is to run chaos tests in production. And there are
okay,
many folks out there who are already running in production, but each and every one of them started off with the first step where they ran these cases in their pre-staging or their development environments.
all right.
All right, so moving on, I think we have spoken a lot about how chaos engineering is typically done. I mean, there are game days that are organized. It was rarely integrated into the CI/CD of your system, I mean, it wasn't seen as a practice where it can be formulated or used on all sort of systems, or it can come in to your pipeline anywhere. But today, I think once we have gotten over these typical practices, these typical practices are basically outdated. They are not the ones which are being followed as modern chaos engineering or cloud native chaos engineering practices. Today, chaos engineering has moved beyond just SREs, and today even developers and other personas are practicing chaos. It's being integrated with your CI/CD. I mean, with your drone CI or Jenkins, GitLab. Everyone's somehow or the other focusing on bringing chaos engineering into their systems, from manual planning and execution to automation. The journey has been long, and while observability was something which was seen as a far-fetched idea for chaos, where it was just some YAML files being run, I think today systems are being observed in such a way where each and every second matters and every second counts, where you are able to see what are the disruptions happening in the system. So these are some problems that we listed out from the existing solutions. They were not automated, there was lack of collaboration, and there was, I mean, it was driven by root cause analysis, and it was not exactly driven by the idea of resolving solutions where the approach should be modern and dynamic, and it should be a collaborative process where teams are using chaos. Multiple teams in a company are somehow in some way or the other inducing faults in the system, and these are being automated and integrated to your CI/CD pipelines, and that's where a better solution of chaos engineering came into play, where we thought of an idea where, why not bring in teams and create a centralized control plane where teams can come in and experiments can be used by not just the SRE but the developer persona as well. There should be public hubs available with a list of ready to use experiments, and we devised a chaos hub, and that the chaos hub basically helps you uh, get in all the pre-written experiments and create a chaos workflow with various experiments suiting your scenarios. It can be integrated into your CI/CD so that you can find weaknesses while you are building, and then observability. Obviously, as I said, you need to impact and manage your SLOs and errors to measure the impact of the chaos experiment that is being induced. And that is where the foundation principles of chaos engineering were developed. So the foundation principles of chaos engineering, according to us, obviously are that it should be open source powered or open source driven. There should be a hub, or there should be experiments that are already there or contributed by the community. So community is, I think this is not something about chaos engineering here, but just cloud native development, that community is key to developing any sort of project out there, and a strong community makes a strong project or a strong technology. And I think the chaos engineering community has been vital in helping us identify various scenarios. Let's say there's the community which belongs to the banking sector, to the automobile sector, to the e-commerce sector, to the telecom sector. These have contributed various scenarios, various use cases, and that's how the chaos hub was built, where the experiments were out there. I mean, GitOps, you need to scale and you need to help. As I said, it's very important that your CI/CD is having chaos engineering not as a commodity but as an essential necessity. And then open API and lifecycle management, just to help you integrate with other potential softwares out there. And observability is key to identify what or how exactly is chaos being induced in your system. And these were the foundation principles of chaos engineering, and that is how chaos engineering was developed, and harness became a part of this journey. And basically the harness chaos engineering is today powered by LitmusChaos. So now finally we are here to talk about LitmusChaos, which is nothing but an open source cloud native chaos engineering framework or a chaos engineering tool, which was founded way back in 2017. We just found the project to test a cloud native data project that we were running. And the idea was just to write a pod delete experiment and a pod network loss experiment, and just to create some normal experiments, test them, and just let it be a closed source project. But sooner than later it became an open source project itself. We donated it to the CNCF. It became a part of a larger ecosystem, where the idea was to make it community collaborative and actually follow the latest chaos testing practices, make chaos engineering a go-to practice. And today I think it's been a flag-bearing project for the chaos engineering ecosystem, and it's a CNCF incubating project. Just became an incubating project in January this year, and now it's just following some amazing principles to help folks induce chaos in their systems.
It's
So
amazing how you started with the single pod. So you started with the single pod deletion, and you created this awesome framework, and it's incubated by CNCF. What is an advanced chaos experiment? If if a single pod is the start, what is the most extensive one you saw that really extensive?
I think the latest experiments that are up on the Chaos Hub, I am really fond of IO Chaos. I mean, IO Chaos is something which is really hard. I mean, it impacts your overall system. Or there's pod HTTP latency. That's one of the latest experiments where which has come out, and I'm intrigued by, I think, these experiments. I mean, a pod delete or a node kill or a container kill was the basics of inducing faults in a Kubernetes system. But with LitmusChaos, I think I'll just take you through the Chaos Hub as well. So if you check out the LitmusChaos Hub, I mean, this is the website, but if you check the Chaos Hub here, then there's a pool of experiments, more than 50 experiments based on generic Kubernetes, AWS, CoreDNS, Cassandra, Kafka, and other platforms as well, which I mean signify that there are so many experiments that can be induced, or so many possible faults, and it's just a pool of experiments. I mean, there's a vast pool out there. These are just the 54 which we created or the community has donated, but there's a lot more. I mean, VMware, we are still developing, so there's that to come. And then I think AWS SSM. I mean, these experiments are still in development, but this speaks volumes of how intriguing our chaos experiments are, what all disruptions that can happen in from an application to your infrastructure.
All right.
So that's about the Chaos Hub, and this is the LitmusChaos website where you can just go in, get your resources, get started with the docs, or with the GitHub where you get some info in the README and how to contribute, raise issues, run your Chaos experiments, start from basics, and then you move ahead. And then there's an amazing community out there, which I think you can check on the Slack as well. There's an amazing LitmusChaos Slack channel where you can join in and ask your questions, ask your doubts, get started with chaos engineering. From getting started with chaos engineering to getting started with LitmusChaos, I think the journey is a vast one, and you can easily, I mean, be a part of the community and get started. So moving back, I think these are just some stats I'll conclude with. It started in 2017. I mean, there's been more than 1 million experiment runs, and the usage growth has exponentially increased over the last few months. And the 2.0 stable platform released last year in August, and now, as you can see, it's adopted by so many amazing folks, and there are more. There's Adidas, there's FIS, there's iFood, there's VMware, Red Hat, and so many other folks are using LitmusChaos, and that's something that has powered harness chaos engineering, which Sayan will be talking about. But I think the idea of powering an enterprise tool or a cloud native solution with an open source solution, which is a CNCF project, which is backed by CNCF, is an amazing idea in today's DevOps ecosystem or DevOps development.
All right. Thank you.
So with this, I will hand over the proceedings to Sayan. Thanks a lot, folks. If you have any questions, feel free to
Thank you.
ask them. And Sayan,
Thank you.
you can take it
It was
from here.
amazing.
Thanks a lot.
Sure. Just give me 1 sec.
Now the live demo.
Yeah. Yeah. I hope my network is a little better now. I am changing it.
Okay.
Should not be
Yes,
a
Sayan.
lag. Yeah. Cool. So let's see if my mobile net can handle the chaos. We'll see.
There will be external chaos, unplanned chaos.
Yeah. All right. So can you see my screen?
I'll just
Yes.
share it. Okay.
Yeah. Awesome.
This is your screen,
So
huh?
yeah, this is my screen. The introduction of harness chaos engineering. Yeah. So I will be talking about the HCE. So I'll be saying harness chaos engineering as HCE for short. So I'll be talking about HCE, the advanced features that you get on top of Litmus, and also the architecture, how we actually do the chaos. And then we're gonna run through a small demo of an application called SockShop, which is like a microservice demo application. So to start with the introduction, what Prithvi just mentioned about what he just explained about LitmusChaos, HC is nothing but a wrapper around the entire thing, around Litmus, giving you all the features that Litmus has, plus a few extra features. By extra, I mean you get added support from harness, you get better authentication, you get more advanced experiments, which is like, I would say, definitely the selling point, because you have more and more advanced experiments that you can leverage, that you can use to create your own scenarios that you can modify to fit your use cases. So that is one of the strong points of
I think
And
that
internet
there is a
chaos.
problem with the network. Yes.
for Litmus, you have to use a cluster and then install your agents and everything. But with HCE, you can actually go to cloud.chaosnative.com, and that should get you directly to the SaaS offering. So you can just sign in with Google, GitHub, or just with your email, and then you should basically be able to connect at most two agents, and rest everything is unlimited. So you can go ahead and play around with whatever you want to in the entire Litmus platform. Cool. So that was the introduction of what this platform is mainly about. Now the experiments, which are one of the best things about using HC, which is you have application specific chaos, you have generic chaos, which is like the basic ones that we just talked about, the pod lead, container chaos, node chaos, IO, and all those things. And also we have VM level chaos. So like we have VMware, and also some chaos targeting specific cloud providers. So for example, in this case, Azure, AWS, GCP. So those kind of things. Those different types of chaos along with the application chaos, you can of course combine them, and like the possibilities are endless, because you can merge, mix and match, and do all these kind of things together in one single scenario. So the scenario building is also something that we are going to see, but essentially you can chain them, create multiple scenarios based on your use cases, and then run the entire scenario at once. So what's exciting about this new thing, this HCE, the wrapper on top of Litmus, is basically it gives you all the features of Litmus, which are nothing but scheduling, the resilience score calculation, addition of custom image registry, monitoring, then your own chaos agents. So we'll be talking about what chaos agent, chaos center, these things mean. But yeah, these are like just an overview of what exactly you get with HC. So you have teaming, you have your RBAC, you have a workflow editor, which you can use to edit your workflows. Then you have the support for GitOps, which is, let's say, if you do not want your data, your workflow data, your chaos data to be stored in the database where chaos, where Litmus or this HCE is installed, HCE as in if on-prem is installed, or let's say LitmusChaos is installed, then you can switch to a GitOps model, which is basically you'll be choosing Git as your single source of truth. So all the data that you're working with, all the workflow data, all the chaos data will be stored in your Git repository. So that way you're spacing it out completely to a separate version control, and you can maintain the data that's specific to your use cases, and not rely on the database that Litmus is providing. And also addition of chaos hub, which is like from where you get all the different list of experiments, right? So that is from the chaos hub. So chaos hub is also embedded as a part of the installation, and of course you can create and add more chaos hubs if you want to. And then you also get control over your chaos results, because then you can export those chaos results into your own solution, yeah, like Grafana, Prometheus, and those kind of things. And also you can enhance your experiments by creating probes, by updating the chaos engine, tuning certain parts of the experiment, and then you can sort of customize it to your own needs. And also
How
the two
easy is
things,
it
which is
to
the
customize? How easy is
Mhm.
it to customize and write your own chaos experiment?
So there are two things actually. Oh, there's one major thing, which is there's this CRD, which is called Chaos Engine, and that is like the heart of where you do the customization on top of your experiment. So, for example, let's say you have a basic pod delete experiment. So the pod delete experiment would have what we call a Chaos Engine, and the engine is like where you give the tunables. Like I want this experiment to run for 1 minute or 2 minutes. I want it to run 3 times in a minute, and then I wanted to target this namespace. Those kind of things are like sort of carried down from the blueprint, which we call as chaos experiment, which is the next slide. So those things are tuned, we can tune it in the chaos engine part. So that CID is what's responsible for doing these enhancements on top of your uh, basic blueprint. So that feature is something which is the chaos engine CID. Yeah. And uh, an extra thing that is also supported by the HC on-prem version, which is the air gap support, which you will not get on the SaaS version. So if you go for on-prem, then all the features that are there, obviously, plus you get air gap support as well. So yeah, that's an additional feature on top of what you get for SaaS.
So when I use HCE, it's not just for Kubernetes. It can be for VMware, it can be for AWS, for Google
Yeah,
Cloud.
right. Okay, just give me 1 second. There's
Yes,
someone at my door. Just 1 second.
we bring. Prithvi, how easy is it? Do you have to learn Go? Do you have to learn Python to basically write these chaos experiments?
So, Walid, I think if you're using Litmus, then you write your experiments in Go and Python. We started off with Go. Most of the Litmus experiments are written on Go, and then now the experiments are written in Python as well, and then some of them are written in Ansible as well. But if you are well versed with Go, then I think writing a chaos experiment for you won't be that difficult.
All right, thank you.
Actually, I would also I also add one more thing, which is we have this Litmus SDK, which actually helps you create this kind of experiments really easily. So I think I believe the SDK is written in Python, if I'm not wrong, but I have to check the repo once. But yeah, with the help of SDK, like if you know a little bit of Python, you can sort of it's like a interactive thing, so you can choose what you want to write and then what type of experiments you want to do, and then you can create your own scenarios on top of like experiments on that SDK. All right. So this diagram right now that you're seeing in the screen, this is basically the um, flow of how a chaos execution would actually happen in Litmus. So this is not the architecture diagram. That's the next slide. This is like how the chaos would actually happen. So what is there in that? Like there's a lot of things in this diagram, but the three important part is the chaos experiment CR, the chaos engine CR, and the chaos result CR. So this is this experiment, this engine, and then the result, this one. So these three are the most important part. Now the rest of them are like helpers of these three CRDs. So what happens is generally the first point would be the chaos experiment. So chaos experiment is nothing but the blueprint of what you want to do. So in this case, let's take an example of container kill. So the blueprint of container kill may be like all the different environments that it supports, the metadata, and like the entire chunk of templates, sort of like a blueprint of an experiment. So like it would have all the metadata, it will have all the configuration, it will have all the environments and everything. So that is stored in this chaos experiment CID, and the engine CID is, and this chaos experiment CID fetches this data from the chaos hub that was hub.litmuschaos.io. So let's say you want to run any generic experiments, it will fetch the chaos experiment from that hub. You want to run a Kafka or something, then it will fetch that from the hub, and that is where the chaos experiment YAML is stored. And now the next part is chaos engine, which is like modifications or like the tunable part of the chaos experiment of the chaos, the entire workflow. So in the chaos engine, let's say in the chaos experiment, I had a few things like environment is app namespace, or um, total affected application percentage, or let's say something like how much time, how much seconds should it run for. So I gave it something like 60. So in the chaos engine, I can tune that. So I can say like, let's not run it for 60, let's run the total workflow, the total experiment for 120 seconds. And then I can also change like the interval. So I can say like run 6 times in 120 seconds. So it'll sort of divide the timing and like run that much times in that 120 seconds. So those kind of tunings we can do with Chaos Engine YAML on the Chaos Engine YAML, and this is also part of the same uh, YAML file. So these are part of the total. These are part of one single YAML file. So at the top you'll have Chaos Experiment, at the bottom you have the Chaos Engine, And then there's also a thing called steps, which we'll be seeing in the demo. But yeah, that is essentially one single big chunk of a YAML file where you have all this metadata. Now, what happens is the chaos engine is responsible for doing the tunings, but it is not what triggers the chaos experiment. So the execution is triggered via something which is called as chaos operator. It's like the heart of the chaos, this entire flow. So it sort of sees that, let's say you try to kill an application on ABC namespace, but the ABC namespace is not there in your cluster. So chaos operator would be the one that will be sort of checking and seeing and validating if that thing, that configurations that you're giving are actually present on your cluster or not. If the policies, the rollback, the RBACs and everything are valid or not. So those kind of reconciliations is what the chaos operator does. And that is like the heart of the entire operation. So once it sees that, okay, whatever configuration you've given, all the validations are right and everything is correct, then this is what will trigger your chaos engine. So chaos operator would trigger that chaos engine, which would trigger the chaos the workflow, the experiment that you chose. So in this case, let's say container kill. So it will see that, okay, your application is there, your container is there. Now I would want to kill it. So let's trigger the chaos engine. So that is when the chaos actually starts happening. Now the happening part, the chaos also doesn't happen in a very straightforward way. They're like I said in a just before that, if you, let's say, give 120 seconds for the entire workflow and you divide it into smaller chunks, let's say 6 times of 120 seconds. So how does the application know that you want to run it 6 times? That's where this chaos runner pod comes in. That's like a helper pod. So the helper pod spins up first. It will see that, okay, I need to run for 120 seconds. So let's say for the first 40 seconds or so, let's spin this chaos job. So that is where one container kill is running. And then let's say for another 30 seconds, let's spin this another pod, which is like the chaos job, like another container kill, so another container kill, so like that. So the helper is responsible for spinning these multiple chaos jobs, and this, all the things are coming from the chaos engine. So that is the entire flow of how it actually happens in our backend. And once the application is finished and all the experiments are completed, the phase could be failed or successful based on how you have configured your chaos experiment, chaos scenario. So once it is done, the chaos result CR is where it stores all the data. So all the data is collected in the chaos result. Now you can either choose to like just see the result and just delete it, or you can also export this data result to your own solution. Like you can monitor it via Grafana, via Prometheus, and those kind of things. So these are the three CRDs which are really important: the chaos experiment, the engine, and the chaos result. Now, with the help of this, you would basically be able to export your data out of your cluster to any other solution. You'd be able to fetch data from, let's say, your private hubs and everything. So in this case, it was a public hub, but it doesn't necessarily need to be. You can also create your own experiments from the Litmus SDK, or let's say you just write it manually in a YAML. You can pull this, the chaos experiment CRD would be able to pull this data from your private GitHub repository or your private S3 container or anything like that. So yeah, that's the three major parts of chaos execution. For the architecture, like I'll make this very simple. So we basically have two things, which is the chaos center and the chaos agent. So chaos center is the where all the activity happening around chaos is focused on. So it would have your database connectivity, it will have your GraphQL server, the authentication server, and it will have your different kind of scheduling methods, cron workflows, non-cron workflows, single run workflows, and then all the things that I just talked about, right? Just give me one more second.
So, Bolina, how is it so far?
It's really interesting.
Yes.
So,
Are you going to start using HCE or LitmusChaos?
I'm trying to find a case where we can implement it, because the software that we're developing is a little bit particular, but yeah, definitely I'll give it a try.
All right. You're very quick in answering your rings.
Yeah. So yeah, like I was saying, so there are two main things, which is the chaos center and the chaos agent. So since the chaos center is the home for all the activities happening around chaos, it's like an umbrella of schedules monitoring, um, GitOps, every and any possible solutions that you would find in the uh, chaos execution, chaos workflow. Everything is controlled under chaos center, and then chaos agent is what actually helps you connect this external cluster. So what I mean by that is, let's say you have two applications. So one application is on running on AWS, another is running on Azure, for example. So and let's say your Litmus, let's say you're not using the SaaS version, let's say you're using the core Litmus version, that also requires a cluster, right? So you have installed this Litmus on GKE cluster. So everything is in a different cloud provider. So how would you connect these two applications that are running on two different providers? So that is where the chaos agent comes in. So you can have your chaos agent sitting on these two providers, and then the agent would be responsible for uh, like picking out the different applications running on that cluster. So in this case, let's say if your agent is installed on AWS, then if you install or run any kind of application on AWS, then it would basically pick up that, okay, you are running this application, so this namespace is available to you, so do you want to run chaos on that namespace? And so like you can filter it with labels and stuff like that. So that way you can target applications running on multiple cloud providers. And this is not just limited to AWS or GCP. There's a list of providers, Rancher and all these things that you can also use and target. So yeah, that's the main purpose of a chaos agent. It's nothing like but a subscriber that's sitting in your cluster where your application is there, so that it can connect to your application. So that's
Okay.
the purpose
So
of. Mhm. Yeah.
I was wondering, you mentioned Rancher as provider. So you have other Kubernetes distribution as a provider like Tanzu, OpenShift, Platform 9, and things
Yes.
like that.
Yeah. We support OpenShift, we support Rancher and those things. So there's a list of supported platforms. I can show you real quick.
And now it's not, I'm not going to do chaos engineering just for the application. I might be doing it for the infrastructure itself, correct? Like after an update
Right.
or something, I
Hmm.
can run
Mhm.
certain chaos experiments to make sure that my infrastructure components and infrastructure for the application is still intact, still reliable, still resilient.
Yeah. Right. So definitely you can do that. So that's why we have IO level chaos, and there's also something called as M agent that's coming up, or like there's a it's in beta phase right now, which lets you target your hardware resources generally, like the lower level of your infrastructure, so that you can exploit your infrastructure more. So previously we had these experiments
Okay,
in the hub, which.
But-
interesting.
And what
Yeah.
if you, how are you going to test your infrastructure? I create a clone of your infrastructure to a different environment and
Uh,
run the test there, because it's very risky to run this kind of test on, well, I heard already that they can be run on production, but isn't it risky really?
yeah, definitely that is risky. So that's why what is preferred is you have a staging environment or separate environment where you do all this kind of tests, especially for the infrastructure. And especially like you can do it in production, but definitely it's risky. So people generally prefer doing this kind of things in a separate environment. But yeah, we do not really clone the infrastructure when we do the testing. Agent directly like targets your infrastructure and exploits it. And let's say something goes wrong, it sort of, there's a rollback mechanism automatically, we call it revert chaos. So it sort of reverts it back to the original state. But let's say you like it doesn't keep a copy. So let's say you target something which is very critical and you cannot revive it back, then yeah, probably you have a broken system. So yeah, that's why it's in beta. We still need to do a lot of experiment on top of it. But like if you generally want to target your intra level components, that's why we had this infra chaos tags, right? So in this case, a disk fill or a node CPU hog or a node drain, these are like stable experiments that are there in our hub, and these are tried and tested. So in cases like this, you can use node level experiments. You can hog, you can do a overload, fill of the disk, and those kind of things, IO stress. So these kind of chaos we do offer, which are tried and tested, but the lower underlying level, which will actually exploit and destroy your infrastructure, that is the aim agent part, which is currently a beta thing. So yeah.
I like your labeling infra chaos. Yeah, love it.
Yeah, so it's like gives the user an idea that what might break your system, so that before they go and try everything, they know it's better that it might affect your system. Cool. So let me switch to the two different phases that I was talking about. So there's the chaos control plane and there's the execution plane. So the control plane is everything that I mentioned, the chaos agent, the chaos center, the authentication server, GraphQL, and everything. For the execution plane, what I mentioned in the previous slide, the chaos experiment, the chaos engine, the chaos result, those things are part of the chaos execution plane. So it's that simple. So chaos control plane requests for data from the subscriber, and subscriber is also something I mentioned, that we have two different clusters. The subscriber is sitting there, which is the agent. So the agent is sitting there. You want to, let's say, target a Kafka pod running, Kafka deployment running on that Azure container, Azure cluster. Then your subscriber is sitting on the Azure cluster. It's seeing that you have a Kafka deployment running. It'll target it. It'll like sort of match the namespace and the label and everything, and it'll run the entire like the entire flow that I just mentioned of fetching the chaos experiment, running the chaos, like tuning the chaos engine, calling the operator. Operator will see if everything is there, and then trigger the chaos experiment. So at the top, you see a chaos workflow CR, right? That is nothing but an Argo controller. So we use Argo behind the hood. So basically, the experiment, everything that you see, the nodes and everything are being spawned up by Argo. And Argo is actually the one helping us to map these kind of different data and sort of visualize and also sequentially do this workflow in a queue format. So yeah, we use Argo behind the hood, who actually takes this workflow CR data and paints the UI. Cool. So let's take a look quickly at the features that it offers in a very quick overview, because we already talked about most of it. So we have the portal, which is the chaos center that I just said, enterprise chaos hubs, which is like both private and public chaos hub. So you can connect your private hubs if you have private experiments that you want to run and do not want to use the public ones. You have chaos scenarios, which is like a chaining of multiple chaos experiments together into a single scenario. Then you have also something called as chaos probes. So currently we support types, which is HTTP, KTS, prom probes, and CMD probes. So these are the four PromQL probes, basically. So these are the four types of probes that we support. And probes are nothing but like extra pluggable checks that you would want in your application. So let's say you want to do pod delete, but you want to do more than pod delete. So you want to delete a pod and then actually want to use the HTTP probe to see if, let's say, there was a service in the same, like you have exposed the service with the same pod, and you want to see when you're doing the pod delete if the service, let's say it's in a load balancer, if that endpoint is still accessible after you are deleting the pod. So that would mean there's something wrong, right? So if you have deleted the pod and then you can still access the endpoint, then something is definitely wrong. So those kind of checks you can configure with the help of probes. So there are multiple probes. So in this case, you can use an HTTP probe to hit the SVC endpoint. But yeah, there's other probes as well. So you can like use a CMD probe to write a bash script and do anything inside the shell to make it more advanced and stuff like that. So yeah, these are advanced checks that you can also do to like, tether to your specific needs. So yeah, that's another feature. For
And
security,
you can
automation, and
visualize,
scalability, we have
so you can visualize these
and
probes in Grafana or somewhere else. So
um
the probes is like the monitoring part of the chaos engineering,
right, not
The
right?
results of
necessarily
the test.
monitoring. It's not necessarily monitoring. It's mostly about um sort of doing the health checks and giving you the result if it's working or not. So you would actually
Okay.
be able to verify the entire workflow in Grafana, but not a specific probe. So you would get the result and everything in different annotations on the Grafana, but not specifically the probe. So you would see that okay, there's a probe success percent that is appended. So you would see what what's the success percent of the probe you applied, but you would not get a visual effect of only the probe in the Grafana. but you'd get
Okay.
the whole thing as a total. Yeah.
Okay. Good.
Okay. So for security, automation, and scalability, we have the option of using the same integration in a CI/CD pipeline, like a wrapper. So currently, you can use vendors like Spinnaker, Captain, GitLab, GitHub Action. So those you can run chaos on these vendors definitely, and it's the same way essentially because it's also uses the chaos experiment, chaos engine, and everything, right? So uh, there was a question previously like what would be the time it would take to run these kind of things in the CI. So it depends on the chaos agent. So let's say by default we give it as a 60 seconds or 1 minute of the 1 minute of time it will take to run the experiment. But to initialize and like get let's say a main cluster or any kind of a cluster on the CI itself would take a minute. So generally if everything is in default it will take about 2 to 3 minutes do this entire process and give you the result back. But that is of tunable. So in the chaos experiment, you can mention that I do not want it to be 60 seconds. I can make it 200 seconds or something like that. So that in that case, it will run for longer. So this kind of things you can do in the CI pipeline. So that would ensure that you have a robust system and that everything is validated in the pipeline itself. And GitOps I already mentioned about. And for the endpoints, you also have hardened images and TLS endpoints that you get as part of security, so that everything is hardened
And
basically.
the the applications that you said that like GitOps that can be run, that on them can be run chaos engineering, it means that they
Mm-hmm.
already have the probes integrated and you can like they're ready and you just run
Yeah, so GitOps is
tests on them.
basically whatever you're doing on the chaos center, right? So that source of truth, the where you're saving it is being changed to Git-based SCM, nothing else. So if your workflow has probes, the entire data would be stored in Git, nothing else. So yeah, it's like a bi-directional flow. So there's a microservice called event tracker which tracks the flow in both the directions. So you will basically be using Git as a single source of truth in this case and scrape out Mongo basically for workflows. So if your workflow has probes, then the probe data along with the entire workflow will be saved in Git. And then let's say you change something in Git, it would auto trigger in the chaos center. So that's the uh, GitOps
Okay,
integration that we have done.
I thought that the applications that you mentioned are already prepared to be tested with chaos engineering, but it's like yeah, a source code.
Yeah.
Thank you.
Yeah. So for the enterprise support, the CI/CD part is a part of the enterprise support. You have integration with APM systems, and of course, Harness's SLA support is also part of that because if you're taking the enterprise support for the community one, you would get community support, but for the Harness one, you'd get Harness SLA support and also the air gap support that I talked about in the beginning. If you take on-prem, cool. So this is just an overview of everything that you get on the community side and extra things that you get on the Harness chaos engineering side. So there's like extra authentication, better authentication, and also advanced experiments that you're getting as a part of HCE. All right, so this one I already talked about chaos center and chaos agent when I was discussing the architecture. So it's the same thing. So I'll be skipping this one. And another thing, which is the CLI, which we use to actually connect the agent. So to connect these two agents that I talked about, right? If you have AWS or if you have Azure and you have two different agents, two different subscribers running on two different clusters on this providers, so you would need to connect them somehow. So this is the binary that is useful, that is used to connect these two clusters, which is chaos.ctl. For the open source version, this is same is called as LitmusCTL. For the enterprise one, we call it chaos.ctl. So it would have some more functionalities down the line. But yeah, for now, this is also publicly available, and it would just take the kube config and it would do a set configuration so that it basically sets your unique account based on the access ID and access secret, and then you would be able to connect your agent in the project and the endpoint that you're running a project on. Cool. And this is also, yeah, I talked about it when I was discussing the experiment section that you have support for multi-cloud. You can target applications running on AWS, running on Azure, running on like let's say VMware or GCP. these kind of things you can definitely target. And for these kind of things, you do not need actually chaosql connected, because some of them are already simple things like AWS instance skill. So you can just skill an instance, EC2 instance in AWS without an agent sitting there. You just have to provide the IAM secrets to like store it as a secret in the cluster that you're running, and it would just scrape the secret out and target the EC2 instance and just drop it with the ID. So there are a few experiments which are specifically only for the cloud. So you do not need a subscriber connectivity sitting there as well. So these are like uh, just specific cloud experiments that we offer. Cool. Finally, it's demo time. Let me go ahead and do a quick demo. So what we have here is I have my Azure cluster connected, and this is a single node cluster. This is, I guess, it is 16 gigs of RAM, 16 GIB RAM, and 4 vCPU. Yeah. So I'm using a strong VM because I'm going to run something called as sock shop, which generally takes a little bit of RAM. So this is Shock Shop GitHub. Let me just give you a quick overview of how it looks like. We just go to the images. This is the architecture of Sock Shop. Let me open this in a new tab. Right. Okay, this is a little small. Okay, this would be a little blurry, but okay, let me try open a new image. So the architecture is pretty simple. Just one second. Uh, never opens the correct link.
Maybe from GitHub,
They don't actually
maybe
have
from
this
the
architecture
GitHub.
on GitHub, surprisingly.
Doesn't.
I don't know why.
Oh.
Yeah, they just don't have this one in GitHub for some reason. Okay. Let me try one more time. This one looks clearer. Yeah, cool, awesome. So this is the architecture diagram of SockShop. So what SockShop generally is, it's a SOC selling application that is purely for demonstration purposes, for microservice demonstration purposes. So it has all these different services or pods, right? So it has order, it has payment, user, catalog, card, and then on the backend, it has a messaging queue with RabbitMQ, which generally pass on the shipping data to the queue master. So these are all like very different things, which individual services that we can use to target and showcase different things. But for now, we'll be targeting this catalog pod. So what it has is, it has two things. It has a catalog pod and it has a catalog DB as well. So we'll be targeting the catalog pod itself. And this is how it looks like. So this is the SockShop application. I already have it deployed in my cluster. So this part that you see scrolling down, moving, this is the catalog. So we'll be deleting the pod that is actually showing the catalog. So this is how it looks like. Um, so this is the one that we'll be targeting, catalog pod directly, not the catalog DB. So bear in mind there are two things. So this is not the one that will be targeting the SQL one, MySQL one. We'll be targeting only the pod.
And,
So what should happen
and it's a
is,
single replica, single pod.
yeah, it's a single pod. So currently there are two modes of deployment. So there's a resilient manifest, and there's a weak sock shop manifest. So those things are also there on test tools. This is another repository of Litmus. So inside test tools, there is a weak sock shop YAML. So this is the YAML that I applied. So in the app manifest, you would find multiple manifests that you can use for testing as well. There's a weak sock shop, there's a resilient sock shop. So in the resilient one, you have 3 replica sets. In the weak one, you just have one. So the weak one is meant to fail, the resilient one is meant to pass. So that's based on what you want to do. So in this case, I've deployed a weak
All
one,
right.
so it's just 1 replica set. Yeah. So we have multiple other options as well. So like in this case, the Bank of Anthos is the one that's useful for if you want to do black hole experiments and those kind of things. If you want to do a complete packet loss. So you can definitely play around with the different manifests that are there. But for this demo, I'm using the weak sock shop. So you just have 1 replica set. Cool. So once we take this down, our hypothesis is this should go away. So this part of the microservice should go down. The DB should still be up, but the service would generally go down, and all the other services, since they're independent, would still be up, and you would be able to see all the other services, but only this part would be completely broken. So moving on to our portal. So this is cloud.chaosnative.com. This is where you can sign up for the SaaS version. So what you have to do is generally go to this link and just sign up either to GitHub, Google, or a local sign-in, and then you should be able to go to this section, go to the onboarding section where you should have a access key and access ID, and then you can follow this step. So you should see this generally on the first page itself. Since I have two agents, I have to do it from this UI, but you should see the screen in the second step. So you can download the chaos.ctl, the binary that I just mentioned. So these are the two steps you need to download. So you can download it from here. Then you have to extract it, give it some permissions, and then you can set the set configuration. So you have to set the account, and this is where you would need the access ID and the access key. And once you do that, you can create the agent with the agent name and the project ID and the in a non-interactive mode. So that would basically connect your agent to this one. So that's what I have done. So I just had this Azure cluster. So I just connected this Azure cluster to this SaaS version. So I just did a chaos.ctl create cluster with a cluster name. I called it chaos second agent, and then I just gave the project ID. So yeah, that's how you connect the agent to the portal. Once you're done with the connection, we'll just go to the Litmus workflows, schedule a workflow, and since I just have one agent, it's already pre-highlighted, pre-selected for me. I'll just go ahead and do next. And for this one, since we are doing a catalog, a normal catalog delete, pod delete, so I'll just select the predefined one and I'll just do some modification to it. So this is the predefined section where you get all the different manifests, all the different predefined workflows pre-configured for you. So you have Bank of Anthos, Potato Head, and SockShop. I'll just select SockShop for now. So this would be preloaded with a lot of other information which we would not need. So I'll just trim this down a bit. So currently you see there are a lot of applications, like a lot of experiments. So I would not need CPU hog, memory hog, network loss, and also catalog disk fill. So I'll just need this one, catalog pod delete. And I'll just go ahead and do edit YAML. So this is the entire YAML that I was talking about. So you have your chaos experiment, you have your chaos engine at the bottom as well. So at the top, you have your blueprint, you're calling the entire chaos uh, experiment. So this is where you're installing the application. So this part we do not actually need because this is a we already have it installed, so we do not need that. So in this install chaos experiments, you see there's a kubectl apply. So we are calling this from the hub.litmuschaos.io. This is where you're actually pulling the experiment from the hub. So this is the chaos experiment YAML, and then at the bottom we have this metadata in the data section. So kind is a chaos engine. This is where we're defining the chaos engine. You can do your tunings in here, and these are the probes that are part of the YAML. So these things you can like if you're an advanced user, you can do it directly from the YAML. But there's also a configurations wizard that's there in the UI which you can use to modify these things, and that'll automatically change it in the YAML in the manifest too. So in this case, these are the steps that we need to take in order to do this. So we would not need install application since we already have SockShop running. We would not need to do a load test. So let me delete that one as well. And since we do not have a load test, we do not need to delete the load test. So I'll just remove that as well. And the type name for this one, I'll just call it week because we have applied the week SockShop manifest, and we should be good. Let me save the changes, and we should see a very streamlined graph, Argo graph, which would just be install the chaos experiment, which is the catalog pod delete, do the pod delete, and revert the chaos. So if we check the namespace, this is correct. So we are checking for the SockShop namespace, and our application is also running on the SockShop namespace, as you can see at the top. So we'll be targeting this namespace, and also we'll be targeting this label name equal to catalog. So just let me go ahead and do next, and schedule now, and finish. So once I do that, my experiment should start running, and we should see a graph like this come up. Now let me open this side by side so you can see what exactly is happening. So in this case, I'll just zoom it out a bit. So the
So this
first
is the container.
It would kill
So
the
it will
pod.
kill the,
Yeah, the catalog pod. Right.
yeah.
So currently,
And
there.
once or so you said
Mhm.
the you said in the beginning the chaos engine by default is it 120 seconds?
It's 60 seconds. Yeah.
60 seconds. Okay.
Yeah.
So the bot
So
recreated.
it's
Okay.
currently installing the experiment. So you would see a helper pod generally spin up, and the helper pod would be the one responsible for creating the triggering the pod delete. So you would see this right now, right? Like once the helper pod is here, so it would take a bit of time, and then once it's done, we should see this thing go down. So currently the timestamp is 84 minutes, right? So this thing would go down, and this part should also just magically go away. So we have pod lead. Currently it's in the pending state. If we open the cluster, so you can see catalog pod delete is in a container creating phase. Now it's actually running. So it's just spun up 15 seconds ago. Now let me check the like this is a watch mode of the sock shop. So let me just check what happens to this catalog pod, and we should see this one go down once the chaos starts triggering. Cool. So you can see the runner is up 42 seconds. So this is the helper pod. So runner will spin up multiple chaos jobs. So yeah, you can see the chaos happening, right? So it got terminated and recreated pretty fast. So it's like catalog is 7 seconds now. The timestamp is updated. And now let me try and refresh the Sockshop application that's running. So now you see the catalog is gone, right? But the other things are working. So
Yes.
the other part of the microservice are not affected. Only the part that we targeted is affected. So you can like do multiple combinations of this to test your specific hypothesis in steady state based on how your use case would fit this requirement. Right. So yeah,
Yes.
uh, that was the experiment that we wanted to show that how you can trigger it. So currently, I think the timer is too short, so it's like 60-second ish, and I think the interval is also very short, so it just triggered once. But yeah, you have to modify the what do you say? You have to modify the chaos engine to make it trigger more. So if I did like 120 seconds, then it would trigger twice and those kind of things. Cool. So that was the demo for
Nice.
actually
Hey,
bringing down.
It's perfect for continuous integration. In that case, it's not that
I
time
like the
consuming.
demo.
Yeah.
Yeah,
I mean, yeah. Go ahead, Paulina.
Yeah, it's yeah, thank you for the demo. Sorry.
yeah, yeah. It's like you can use it in multiple scenarios in your CI environment, in your CD. Like yeah, there's multiple use cases that you can use this for. Cool. So for future roadmap, we wanted to increase more. Uh, we wanted to add more support for non-Kubernetes infrastructure level components, like we talked before, and for like application specific chaos. We already do have a few application specific chaos, but yeah, we would want to add more of the application specific chaos, which has native faults and health checks. And of course, the chaos SDK we do have, but it can be improved. Any of the you know software is like a continuous process, so we would love to improve the chaos SDK for creation of more user defined experiments. And then currently we support 4 probes, which we would also want to increase the type of probes that we support in the long run, so that the users get a diverse steady state hypothesis validation, and they can run exactly what's on their mind and like explore with more possible scenario opportunities. And then also improve observability for chaos experiments, and definitely add more type of chaos, which are like which is also planned for HC by adding more and more advanced chaos experiments, so that people don't get blocked by the limited choices, and like have more opportunities exploring this kind of experiments. Cool. I
Great.
guess that was
Uh,
it for us. Yeah. if you have
Yeah,
any
thank
questions.
you. Thank you very much, Sayan. It was very
Mhm.
informative, theory-wise, and the demo went smooth. I like the demo. It's a very simple use case, but it shows the power of chaos
Yeah.
engineering. I mean, yes. And I see that in your clock it's like 11:30, nearly midnight.
Yeah.
Yeah.
Thank you for staying
Yes.
up late.
Yeah.
And
No problem.
yeah, we appreciate this. We appreciate this very much.
Yeah, thanks a lot.
Any questions,
We'll use it
Polina,
in
or any
our
follow-ups?
pipelines. Yeah, we'll check the infra chaos. So,
All right.
Yeah, definitely.
thank you.
Okay. So there's no questions, and I guess we kept you up. And yeah, so we'll see you again, hopefully soon. And hopefully that we will start using chaos, LitmusChaos, and harness chaos engineering. And we start basically adding resiliency to our applications. The only thing that I have is that most likely that not every application will require resiliency. Now there is more focus on sustainability. So basically,
Right.
you would like to stay away from resiliency whenever you don't need it. Like you shouldn't be, what do you think? You shouldn't be like 100% resilient. There should be
Okay.
like
So,
trade-offs between
um,
resiliency and sustainability.
right. So, definitely for more important products or whichever has a more
Yes.
priority, I would definitely say a resilience check is a must. But yeah, for other products, sustainability is definitely a plus. And also there's
Okay.
something like nightly builds and like those kind of things, right? So you can keep it there in the pipeline so that way you always get a validation continuously, and then you're at least secure and like happy that everything in my system is resilient and I don't need to do it every day, but like maybe monthly game days or something like that keeps like helps keep
Yes.
your resiliency in check. Yeah.
Correct. Yeah. Uh, Thank you once more, Sayan. It was a pleasure having you both, Sayan and Prativ, and would love to see you again on this series. Thank you, Belina, for hosting us, and wish you the best in your meetup.
Thank you. Thanks a
Thank
lot
you for
for
having me.
everything and
Okay.
help.
Thank you.
Bye. Thank you.